Hi, this is Clay, and I'll be talking to you about continuity. This is on the AP Calculus AB test, so it's kind of useful to know. I'll just read off the definition of continuity and explain it. So it's continuous if there's a limit at a point exists, that point actually exists, and those two equal each other. So I'll go through these problems and just circle yes or no. They're already circled a little bit because I have to run through this once, but I'll just explain why they're the answers. So this first function is f of x equals x squared. We need to find out if it's continuous at x equals 3. So at x equals 3, the limit does exist, and the point exists, and those two are the same value. So yes, it is continuous. And then we have f of x equals 1 over x, or x to the negative 1. We need to find out if it's continuous at x equals 0. And since the limit from the positive value approaches infinity, but from the negative value approaches negative infinity, the limit does not exist, so therefore it's not continuous. We don't need to go any further on that one. Now at x equals 6, the limit from both directions does exist, and the point exists, so it's continuous. And now x cubed. I've said that at x equals 2, the y value is actually 0, so there's a hole there, and the point is actually down here. So the limit, as x approaches 2, I'll just do this bottom one first and go to negative 1. The limit, as x approaches 2, it equals this value, or 8, but the actual value is down here at 0. So those two do not equal each other, so it's not continuous. And then x equals negative 1 is just the same point on the line, so it's continuous there. And then I've said y equals sine of x, and then at pi over 2, there's the hole there, it doesn't exist. So we need to find out if it's continuous at that point. So the limit, it exists because they both approach the same value right here, 1, but the actual value does not exist, it's undefined there. So this is not met, so it is not continuous.